Hello everyone, how are you all? Welcome to the class students. Today we will start second chapter of physics and the name of that chapter is physical quantities and measurement. Now you know that density of an object that is defined as the mass of an object is given volume. That means density is equal to mass upon volume. You know the density is defined as the mass per unit volume. That means density is a physical property of matter and the derived physical quantities. Here the formula is given that density is equal to mass upon volume. Next one is SI unit. So what is the SI unit of density? So SI unit of density is kilogram per cubic meter or kilogram meter cube, and density of a material is to be 1 kilogram. That means the density of material, it is said to be 1 kilogram per meter cube when the mass of 1 kilogram is packed in a volume of 1 meter cube. A numerical is given here. A block of metal occupies, its volume is 10 centimeter cube and weight is 33.5 kilogram. So what is its density actually? You know that volume is given and mass is also given. So what is the density? The density is equal to mass upon volume, and you will find its density is 3.35 kilogram per centimeter cube. And second example is mass of here a container filled with 60 centimeter cube of liquid, its weight is 90 gram and a container along with 72 gram. Find the density of liquid. So here for this you will find the mass of container 72 gram and mass of container plus liquid is 90 gram. Now mass of liquid is equal to 90 minus mass of container, that is 18 gram, and volume is given here. So density is equal to mass upon volume of liquid. So 18 divided by 60 and you will find 0.3 gram per centimeter cube. Next is measuring density of solids. So it is comparatively easy to find density of a regular solid. We first measure the mass and volume of the solid and then divided the two. Why? To find the density. The mass of an object can be easily measured by using a beam balance. To calculate the volume of regular shaped objects, we need to find their dimensions. Okay, in case of irregular solid, measuring density is a bit tedious work, and we can measure the density of irregular solids like a stone, a block of wood or a key by using measuring cylinders or eureka can. Now measuring cylinder. You know, a measuring cylinder is an instrument which is used in laboratories. That measuring cylinder is used in laboratories and it is cylindrical in shape and it has marking on it to measure the volume of liquids. The measuring cylinder that is given here. Now the given step to measure the volume of the irregular solids, we will use such things. And what will you do? Tie a thread with the irregular shaped solid object, immerse the object completely in the cylinder containing water. This will result in change in the level of water, and when you will note the reading of the final volume of water in the cylinder. To calculate the volume of irregular object, subtract the initial volume from the final volume and then calculate the density. Now students, how will you calculate the density? So finally the formula is density is equal to mass upon volume. Then finally the mass which you will find after, how will you find the mass? From initial volume to final volume. You will find the mass. Here mass is given and you will find the volume by V1 minus V2 or V I minus Vf, and you will divide the mass upon volume and find the density. Then second thing is, what is this Eureka can? To students, Eureka can is a container which with a spout near its top, and Eureka can are also called displacement vessels. It is based on Archimedes' principle, according to which the amount of water by an object is equal to its volume. It is Archimedes' principle. It is very important. Now, so this is Eureka can you are seeing here, and it acts as the Archimedes' principle. Now, by this method you can find the density, and the remaining topics of this chapter here after density, the next topic we will discuss in our next video. Till then, thank you everyone.